pressure influence. But then you made a vacuum experiment and you really showed that pressure does influence. This is really great, that's why I completely agree with you that pressure does influence the phenomenon. Well, it was supposed to begin your attempt to explain heap squelching. However, I also asked a question in my brief questions. In fact, I'm not really agree with your explanation for this model. However, this is what we're going to discuss also. And certainly mathematical model with these equations, I didn't, I couldn't understand them because it was rather fast shown. However, I hope during discussion also I will ask several questions for better explanation of your mathematical model. However, we could see that it gives good predictions for your numbers. You really prove by experiments some of your dependencies with linearization and etc. However, there were some negative points in the report. I would say that, for example, such thing as I mentioned, I not agree with your explanation for the heap version because there is some kind of contradiction. You're saying that your heap, that you have some convection of particles. However, at the same time, you say that heap is moving because of air drag as one substance. For me, this is kind of contradiction. That's what I want to ask further. Your explanation for the pressure influence. This explanation that there is some electricity field and also hits of particles. You know, this seems a kind of not very clear for me. At the same time, you didn't mention friction between particles and how does air flux also influence on the movement of the slide of particles from the top of the heap. So that's also for the discussion. Your explanation for the wall roll. Yes, we have seen experiment when you said that walls can't make the heap because the main still is pressure. However, I can't understand what's in. I want to see that there is some connection between pressure under the heap and the walls because as we could see on your slides, we could see that heap doesn't touch the walls in the very end, and so I can be pretty sure that there is no air flux which can go under the heap and change this pressure gradient, which is you were showing that the pressure is high over the heap and is low under the heap. However, I want to say that if a heap doesn't touch walls, there can be some air flux which neglect this lowness of pressure underneath. So I want to hear some estimations on this point. Also, as a bet, I can say that there was a low number of the points on some plots, and this is, well, maybe reduces the quality of your work, and also friction between particles, I already mentioned this. However, as a general impression of your report, I must say that you really have a very good mathematical model and scientific approach of your efforts. However, with relevant physics, I am not completely agree with all of your points, and same I can say that with experiments I have also some questions. So thank you. Let's proceed with the discussion. Points, I think you better attach your laptop here.
Okay. We have 10 minutes for this.
So let's first talk about some also general points for the physics, and the main question is, can you show me this slide? This one.
50.
Yes. Thank you. We can easily see that here heap doesn't touch the walls. And so with your slide where you show that there is some low pressure on the heap, well, not here, but still, you are showing that there will be low pressure when the heap detached and here high, certainly because there is no air. And still, how does it fit the final results with this heap when air can go under the heap?
I guess like same explanation can hold because if you look at the last picture, there is certainly sure that it actually can be detached here, right?
Yes.
And like same phenomenon will happen. The air will come inside through here, and therefore, since the air can come inside through here, I guess the same pressure gradient can happen.
But still, if first there were totally no air under the heap, and in this case there can be some air under the heap, so doesn't it change your pressure gradient?
I actually can understand what you mean, but in case like the sand is first connected to the container, and that case, there's no the air can
Yes.
go in between it, right?
Yes.
And due to such kind of fast acceleration by the container, there can actually be some kind of air inside, right?
Yes.
And won't that cause the same pressure gradient?
Well, I disagree with you. Because if in one case such layer of particles detach, then no air can pass here, so we still have some atmospheric pressure here, and pressure is something, well, I assume close to zero under the heat. However, here we will have same atmospheric pressure over here, but already some air pressure under the heat.
Oh, I understand that. What kind of phenomenon do you think will happen?
I'm asking you, in fact. That's what I'm interested in.
Oh, I guess I can fully understand your question, but I guess in case of such kind of mention, actually when it is great, for considering a small amount of time, what you can see is actually the same effect. So I think they actually, considering a small effect of time, we can actually see the same effect.
So, but, okay, qualitatively, maybe, I agree with your explanation, but also the question is, will these air fluxes try to, move these particles together with them? So to add some directional movement, will particles move together with airflow under the heat? Can it be like this?
Yeah, definitely, I guess.
Okay, so I want to pay your attention to this point that still this point wasn't mentioned in the report. However, I probably agree that well, on the qualitative the effect will be still the same, but on the quantitative level I think there will be some difference. So let's go further. Once again, I mentioned my words about some contradiction between your theory of the air drag movement and movement because of convectional fluxes. So can you explain me still what does happen? Do you really think that air drag moves the heat like one body, but at the same time some particles move inside it?
Can you clarify your question?
Well, if we have heat, which is in fact all the time moving like this,
Yeah.
but at the same time you want to say that air drag moves this whole system to the right, for example, to another heat.
Maybe you have misunderstood what I meant by air drag. But air drag, I meant by the airflow inside through such kind of
No,
the
here, as I understand,
Yeah.
you say that air drag here is bigger and some air flux, and this pushes all this heat
I
towards
understand.
another one.
If you look at the picture, this picture again, this 14, and in the one steady heap state, it is symmetrical to the center, which means that the air
so
drag inside here and here is
this-
same.
This scheme is built for the steady state.
Yes, this kind of
Unfortunately, that just wasn't clarified in your report.
Oh.
Well, still, now I'm satisfied with your explanation, because now, yes, I do believe that in steady states we can neglect these pressure effects. I agree with you, and yes, your mathematical model, as I understand, also is built for steady state.
Yeah.
Okay? So, thank you. However, I also must notice that still your explanation for the merging of heaps have only qualitative type and don't have quantitative model. That's minus, but still it may agree. Also, another question is about angle theta. You said, as I understand, that with amplitude it grows to, well, it just grows, yes?
Yep.
Can you show me this once again?
Amplitude theta.
Yes. And as we can see, there is, when we will increase amplitude, tangent theta is, will finally go to some constant, some constant value, or it will increase infinite to infinity.
I guess this, I will apologize first about that. I didn't amplitude higher because the vibrator itself
The
had
speaker has sound. Yes.
yeah. And also what I think is that there's a repose angle, right? You know it?
Yeah.
That is the maximum amount a heap angle can get, right? So even we increase the amplitude, the maximum height, if the maximum inclination it will get is a repose angle, and I guess no more it can go.
Okay.
beyond the
So also, good point. Unfortunately, I hasn't, maybe you haven't paid much attention in the report to this. Well, I want to state that yes, I agree that there must be some constant value, some biggest possible height, and this is certainly good. But can you explain why there will be this maximum height? Well, also, can you turn to your mathematical model? Oh, okay. So why will times theta go to the constant? Because here still there are dependencies. What exactly is the reason for it coming to a constant?
May is whiteboard.
Yes.
Actually, in this term, what I failed to put in account was the friction in between the sand particles. However, if you put that into constant, what you can see is that in some kind of container, there are sand particles, and under, like, if there are several layers of sand particles, there are friction in between the sand particles. Am I correct?
Yes.
And like their kind of angle, like if it goes higher than this angle, then the sand particles will just slide. So therefore, there's a maximum angle, like such kind of angle, and we call this a repose angle. And I guess like if you consider the friction in between the sand particles, I guess a repose
it
angle
will give
be
you the answer to this. Well, but in your in the one part of your report, you mentioned that when you're explaining pressure influence, you explained that this is because of some collides between particles and because of some electricity between them.
Yeah.
But you didn't mention friction there between particles, that it still changes the effect.
I guess I didn't mention it because I guess such kind of friction in between the particles only gives a small amount compared
So
to the.
you want to say that it is smaller than these collides and electricity loads?
Yeah.
Okay. I didn't make any estimations on these points, so I can't exactly say am I agree with your words or not, but this is your opinion, and I want to say that it seems rather physicist and rather qualitatively correct. Okay, and once again, we have only a lot of time, so can you briefly explain me once again how your mathematical model works?
Oh, briefly, my mathematical model works.
Yes. What are the main equations you use?
First of all, this is the basic equation I had to solve. And this equation is consisted of two parts, the diffusion term and the vibration term. The diffusion term actually explains the surface slide here, and actually I used the diffusion term according to some kind of papers I found, and I thought it was a valid model because it actually explained some kind of shift, the standard shift from the high place to the low place. And that's the first term. And the vibration term actually, that's the height expansion term. And what you can do is like, as they give the vibration power at the center, and when the sand is just nicely packed, it'll a little bit become like this. The height in between the sand will increase, and such kind of effect I put in the vibration term, omega h, and it actually is proportional to the vibration of power and also the height of the expansion. And we'll go on to the next slide.
Well, unfortunately, we've done the time, so I just want to summarize what we talked here about together. I want to say that in your report you mentioned very great and relevant physics related to the steady state of the heap and to the processes of heap formation. However, I want to state that there were only some qualitative explanations for the heaps merging. Still don't feel very clear with the influence of the air track. With your pressure influence explanations, I want to say that this unfortunately minus that you hasn't explored air fluxes that can come under the heap. However, you built a mathematical model with great prediction power, so thank you for your report once again.
First of all, I want to ask for some parameters. Do you think that the density of the grains has an influence of the phenomenon? Yes or no?
Certainly yes.
Okay, and you?
Density of the particle?
Yes. Yes or no?
Maybe yes.
Okay. And does the form of the container have an influence? When I have a wider container with more spheres in it, with more sand, will it cure a longer time until the heap occurs? What do you think?
Certainly we have bigger amount of particles, then in our steady state we'll have something else.
So will the time be longer until the heap occurs or not?
I assume that it will be longer, but I haven't.
And what do you think?
Actually, I have conducted the same experiment with two having the same different dimension, one small and one large. And actually the hip angle of the last one steady hip state actually remained constant, but only time to actually make the difference was different.
Okay, thank you. What do you think would happen with very high air pressure, so 200 bars or something like that? 200 bars? 200 times the atmospheric pressure?
The guess there will be not that much difference.
Okay, no difference. And what do you think?
With such a big pressure, I'm not sure that the whole loudspeaker will move.
Yeah, but the phenomenon will occur. What do you think? Yes, or no?
Yes, it will be even better.
Okay. And so the next thing, we have this equation for the shaker. It's a driving oscillator. Do you agree? And the problem here is that the solution of this equation is not a sine wave as you assume it in your theory. So mathematically, you cannot assume that you can take a sine wave and calculate the acceleration as you've done. Do you agree with this?
Can you explain how this is right?
So this is a thing of the sine wave and the cosine wave overlap. The solution of this question.
I'm not sure how you can say this because I actually gave the vibrator power, but I'm not sure why this MG term connects. But anyway, if we since the vibration is given by the vibrator and the vibrator actually forms a sinusoidal wave, I guess my assumption of the sinusoidal wave could be still hold.
Okay, I don't know. I agree here. What do you think?
Well, I agree with respect to Porter that with a big enough loudspeaker, we can control that this will be a sine and with no influence of the heaping myself.
Why do you think that the simplification to 1D or 2D is justified? Because I think that the friction of sidewalls will rise. Do you think that will have an influence? Yes or no? Just yes or no? Short answer.
Small influence.
Okay.
One
Do you
is
think?
acceptable.
Yes.
It does not affect the hip inclination itself.
Okay.
Okay,
Thank you.
You have time for preparation.